Okay, this is Dr. Williamson going over problem homework chapter 6, number 47. When 25 mils of half molar sulfuric acid is added 25 mils of 1 molar potassium hydroxide in a coffee cup calorimeter at 23.5 degrees Celsius, and the temperature rises to 30.17 degrees Celsius, calculate the enthalpy in kilojoules per mole of water formed. Assume the total volume is the sum of the volumes and the density and specific heat capacity of the solution are the same as for water. First thing I have to do is write down the balanced chemical equation. So here I have the balanced chemical equation. I've taught you guys how to do this, but this is the balance. It's an acid-base reaction. That's the balanced chemical equation. To calculate the amount of heat that the calorimeter absorbed from the chemical reaction, I'm going to have the mass times the heat capacity times the temperature difference. The mass of the solution in here is going to come from the volumes of the solution. It says, assume the total volume is the sum of the volumes. So 50 mils plus 25 mils plus 25 mils equals 50 mils. And the density is the same as for water. Density of water is 1 gram per milliliter. I'm going to take that to 4 sig figs. So that means the 50 milliliters of solution will have a mass of 50 grams. And that's where I get this 50 grams right here. Where do I get the heat capacity? It says, assume the specific heat capacity is the same as for water. And the specific heat capacity is 4.184 joules per gram per degree C. And then the delta temperature is T final minus T initial. The final temperature is 30.17. The initial temperature is 23.5. When I do the math, I get 1395 joules. This is 3 sig figs here. That's 4 sig figs. When I subtract these, I get 3 sig figs. So I put my answer in kilojoules, which lets me express it as 3 sig figs. The heat of the reaction will be equal and opposite to the heat of the calorimeter, meaning it'll be the same number, opposite sign. So that'll be negative 1.4 kilojoules per mole. Now what I need to do is figure out how many moles of water are formed. So I have to figure out which one of these two, this one, oh boy, that's a terrible color. Which of these two, this one or this one, is the limiting reactant. 25 mils is 0.0250 liters, and the sulfuric acid is 0.5 moles per liter. And I know that from the balanced chemical equation, for every 1 mole of sulfuric acid, I will get 2 moles of water. So I'll go 2 moles of water. I'll put W for water here because it's kind of hard to write with my mouse. For every 1 mole of sulfuric acid. And that's going to give me 0.0250 moles of water. And I have 25 mils of 1 molar potassium hydroxide. 25 mils is 0.0250 liters. Put my decimal point clear. And it's 1 molarity, 1.00 moles per liter. Boy, that looks really bad penmanship. 1.00 0.00 moles per liter times the balanced chemical equation. For every 2 moles of potassium hydroxide, I'll get 2 moles of water. So I'll write 2 moles of water, 2 moles of potassium hydroxide. When I'm done with my math, I get 0.0250 moles of water. So neither one of these, the sulfuric acid or the potassium hydroxide, is the limiting reactant. And I know that the reaction is done in stoichiometric amounts, meaning they both run out exactly at the same time. And I will have only 0.025 moles of water created. The enthalpy of the reaction will be the heat of the reaction. And they wanted it per mole of water, so per mole of water. And that's going to be negative 1.4 kilojoules divided by 0.0250 moles of water, and I will get negative 56 kilojoules per mole. And that will be my enthalpy of reaction per mole of water. And the negative sign makes sense because negative means, oh, wait a minute here. Final minus initial, so the heat went up, so it's giving off heat. Okay, well, let's ignore the negative sign. What matters is that it absorbs 56 kilojoules per mole. Okay, and not that it's absorbing, it's actually giving off 56 kilojoules per mole. I did have it right. Let's take a look at that. I brain farted myself. The heat of the reaction is negative 1.4 kilojoules because the temperature of the cup calorimeter went up, right? So the calorimeter absorbed 1.4 kilojoules, and that's because the reaction is giving off 1.4 kilojoules. And the minus sign means the reaction is giving off 1.4 kilojoules. And the enthalpy is negative because, again, the reaction is giving off 56 kilojoules per mole. Okay, I had it right. I outthought myself. Anyway, that's problem 647. I hope that helps. I'll do some more later.